Hi, my name is Dominik, and in my today's talk, Going Beyond with Strapi Plugins, I am hopefully going to teach you something new about plugins and plugins inside Strapi. Firstly, let me introduce myself. My name is Dominik, and I work as a Strapi and React developer at Notum Technologies in Brno. Other than that, I like to talk about coffee, cycling, or well, really any technology in general. So if you want to talk to me, you can hit me up on LinkedIn. Let's look at today's agenda. Firstly, we are going to go over some basics and we are going to learn what basically are plugins. Then we are going to look at the possibilities and what we can do with plugins inside Strapi and why we should use them. Then we are going to look at some technical details and what to do and what to avoid when developing Strapi plugins. At the end, we are going to have a quick little demo session where I'm going to implement a Strapi plugin which is basically going to be our own small little ChatGPT application using the OpenAI API. So let's jump into the first section. What are plugins? Well, a plugin is a piece of software that can add specific features or functionalities to your application, which can be large or small, whatever you need to implement, and you can enhance its capabilities without modifying the core code or basically minimally modifying the core code of your existing application. What are plugins inside Strapi? Well, the good thing is that Strapi plugins have always been in mind when developing Strapi, so it is really extensible, and basically all the pieces of the admin application which you interact with are implemented as plugins. These are basically something such as base plugins which you cannot uninstall, but you can always add more plugins. So as I said, they basically allow you to add features without having to modify the code base a whole lot. They are also great for building community because this means that the Strapi team can focus on the main parts of the application which need extending. And if you have a specific feature in mind which you think that the community could benefit from, you can implement it yourself and then publish it for the general public to use. They also have great documentation. This is basically true for all Strapi, but the plugin documentation is really great and goes in depth to what you need to know about implementing plugins. They also have a CLI, which you can utilize. You should already probably know this when implementing custom APIs and so on. It's really great. It can save you a whole lot of time. You can bootstrap basically anything which you can implement inside Strapi. And then there's the marketplace. When getting new plugins for your Strapi application, there are a couple of ways which you can do that. Basically, you can go into GitHub, download the plugin that you want, you can put it inside your application, build it yourself, and use it as you wish. You can also modify it this way, but there's also a simple way. If you want just plug and play functionality, you can take a look at Strapi Plugin Marketplace, which is basically a list of plugins which the Strapi team has looked at and they think that they are beneficial for the whole Strapi community. So these are basically going to work great and they are only a couple of clicks or commands to install, which is really great. You can basically publish or rather implement a plugin and publish it on the marketplace for others to enjoy. Let's take a look at some possibilities and why you should basically think about implementing plugins inside Strapi. So at the core, they are basically everything you can do in Strapi that you already know and more. Other than implementing the controllers, the services that you already know, you can also register new translations. You can create custom content types and fields. You can style them any way you want. If you are creating a page builder application, basically you are able to render these fields as you would render them on the front end, which is going to give your users more preview of what the final product is going to look like. You can use the feature injection. So this means that you can create new buttons inside the interface. You can create new menu links. You can create new sections in settings. You can use the hooks, the reducers. Basically, you can tap into the global Redux store, which is inside the Strapi application, which is really cool. You can also register crons. You can also extend other plugins. This is basically what I've talked about, that really Strapi is really extensible. So in itself, Strapi plugins allow you to move the content wherever you need it. It's like if you think that the content manager is not enough for your needs, if you have some specific functionalities which you need for your users, plugins are a really great way to provide this functionality for the end users. How do we at Notum utilize plugins? Well, that's a good question. We have a couple plugins which we have published at GitHub and Strapi Marketplace. You can take a look at the screen. I'm not going to go over all of them. But basically, we are most proud of currently of the location plugins. Plugin which is gaining traction within the community, and we've received a lot of positive feedbacks, and also other open source contributors have contributed, which is really great. We also use other third-party plugins so that we can save time when we develop solutions for our clients, which is really saving a lot of time. So this is probably the main benefit of plugins, and it is that they save really a lot of times. Let's look at some technical details of plugins inside Strapi. So you can think of a plugin inside Strapi as two parts. There is the admin part and the server part. The admin part is basically what the users interact with inside the application, and you can think of it as a mini React application. So if you are familiar with development in React, you are basically going to feel like at home. And then there is the server part, which is basically a mini Strapi API with some boosted functionalities. So you should also be familiar with this if you have opened any file inside the Strapi application. What should you think about when you are getting started with Strapi plugins? Well, the first thing that you should always ask yourself is, can I benefit from implementing this feature as a plugin? Plugins are really great because you can basically implement them once, you can share them with the community, and you can reuse the same code as a plug and play block in multiple applications of your own, which is really great. The downside to that is that they generally take longer to implement, and they offer less default logic, which you are going to get from the core Strapi application if you are developing one. So it's basically you get more options, but you have to do more things yourself. So if you have decided that you can benefit from implementing a plugin, that is really cool, and now you should design your data and business logic. This is a really crucial part because you should design the data such that it can work independently of the application which is plugging into. So if you design the plugin around data or business logic which is inside one specific application, then you are wasting the potential of implementing the plugin, because then you wouldn't be able to transfer this plugin to another application without having to move this very specific logic. So if you've designed it and you are ready to implement the plugin, you should always utilize the CLI. As I've talked about, it's really great. It makes your life a whole lot easier. You can create and bootstrap basically everything, controllers, services, content types, and so on. And you can also use it to debug potential issues which you may encounter along the way. Then you should always mind your steps. Basically, I would recommend that you always implement the two parts, the admin and the server part, separately. This is because when you are implementing the admin part, you always need to rebuild the whole front end in between your changes. You can utilize the watch admin flag which is great, but if you are only changing something in the server side, or rather the API, it's going to take a whole lot of time before you can interact with the application. So you should always be mindful of which part you are developing, and start the development with the specific flags you should need. Then you can use the design system. This is really great because you do not have to bring your own styles. You can if you want, but if you just want to keep the default styles from the Strapi application, you can take a look at the design system on the link which I am going to provide into the description. They also have a storybook where you can play along with any of the components, you can search them and so on. So that is really great and also saves a lot of time on developing new plugins. And from now on, it's mostly the experience you already know. You are going to implement API, you are going to implement the same structure, which is controller, a route, a controller, a service, and so on. So now we are on your way, and there is basically nothing new if you do not need any of the features which I have mentioned previously. Alright, that's basically all from the theory side, and now let's take at how we can implement our own little ChatGPT clone inside our Strapi application. Alright, let's jump into the coding session. So what I have right now is a Strapi application created with the create Strapi app command available from the docs. And I have also bootstrapped a responder plugin using the Strapi CLI, which you can access with the yarn Strapi generate command. So firstly, I need to register my plugin. To do that, I need to create a config/plugins.js file in which I am going to be exporting an object, and this object is going to contain the name of my plugin, which is going to be enabled, and the path in which Strapi can resolve this plugin. So let's save that. Then we are going to be defining routes for this plugin. So what we have right now inside this plugin is some default bootstrap behavior. We are going to leave that as it is, and we are going to be implementing our own route. So firstly, let's implement post, which is going to be basically handling the logic when user submits a query and wants to receive an answer. So we are going to be defining a method, which is going to be post. We are defining a path, and then the handler, which is going to call the controller, which we are going to implement later, and return the data to the user. And lastly, we are going to be defining some config. Right now we are going to be disabling authentication to make it easier for the purpose of this demo. But if you wish, you can also tap into the content API later on and use the permission system from the settings and so on. Then we are going to be implementing a get method, which is going to list all of the method responses which the user has created, giving it the same config. And finally, we are going to implement a delete method because we know that everybody asks dumb questions sometimes, and it also has the same config. So this is all for the route, and then we are going to take a look at the controllers. So right now we have only one controller, which is the basic bootstrap one, but I am going to be implementing my own, which is going to be called responder controller, and we need to export it as well. Right now we have an issue because it is empty and there is nothing exported, but we are going to do that in just a second. So let's jump into the responder controller, and we are going to implement it. So we are going to be using the strict mode of JavaScript, and from this file we are going to be exporting an object. So firstly, let's implement the ask method, which is going to be the post method, which is going to be asking the questions. So we'll open a try catch block. In the try, we are going to be trying to receive a response from the service, which is called responder service, and we are sending it the body, which is going to contain the query which the user is going to be asking. And in the catch block, we are going to be just handling some general error, but you can handle it as you wish. Then we are going to implement the getAll method, which is basically going to be the same. We are opening a trackage block, we are getting some response from the service, and finally we are throwing an error if anything bad happens inside the method. And lastly, we are going to be implementing the delete by ID method, which is going to be also the same. It is going to ask the responder service to delete some item from the collection. And finally, we are going to be throwing 500 if there is an error. Then we are going to take a look at the services. So we are going to do the same. We are going to import the responder service, and we are going to be re-exporting it from the index files. Then we are going to implement the service. We are also using the strict mode. We are going to be importing the OpenAI from the OpenAI library, and we are going to initialize it with the API key, which is set in the environment variables inside the project. So what we need to do is also export an object, which is going to have all the methods inside. The first one is the ask method. Basically, the first thing we have to do is parse the body, which is going to contain the query inside a JSON object. Then we can destructure it and return if the query length is less than 5. Since we are paying for the tokens, we do not want to waste any of them, so I have decided that if the query is less than 5 characters, you should not get any response back. Then we are actually going to ask the AI API to generate a response for the query. So we are using the GPT 3.5 turbo model with our user's query. Then, if the responses come back and there is at least one response, we are going to save this response into the database with the corresponding query. And finally, we are going to be returning the completion to the user so that it can be sent back. Then we are going to implement the getAll method, which also has a query so that we can possibly use filters and so on. And this is basically just going to be using the entity service API to find all the queries, all the responses rather, with the user's query. And finally, we are going to be implementing the delete by ID method, which is also going to be using the entity service to delete a specific item from the database. So we can save that, and then we can continue on to the front-end part of the application. Alright, let's take a look at the front-end part of the plugin which we are implementing. So firstly, what I want to do is I want to implement an API which is basically going to be an object containing all the calls to the backend so that we can get it out of the way. So let's create a request list which is going to contain methods for all the methods which we have implemented on the backend. So I'm going to have a getAll responses, which is going to fetch from the /responder/getResponses using the get method. If the data is okay, I'm going to return it. Otherwise, I'm going to be throwing an error. Then I'm going to create the post request, which is basically going to ask the responder with the given query in a stringified string, or well, JSON. And if the data is okay, again, I'm going to return it. Otherwise, I'm going to be throwing an error. Finally, we are going to implement the delete response, which is going to send a request with the ID using the delete method. And I'm going to return the data if the response is okay. And lastly, we are going to export this object. Then we can take a look at the front-end component. So what we have right now is a single query component, which is going to represent the accordion, which is showing the query. So firstly, I am going to have an expanded state, which is going to tell me if I should show the response to the query or not. Then I am going to be using React query to handle queries and mutations. So firstly, I'm going to implement the delete query mutation using the request list.delete response method, and on success, I'm going to be invalidating the responses. Then I'm going to actually render the content. I'm going to be showing an accordion, which is a component from the Strapi design system, which is going to be showing a toggle. This toggle is used to delete the query if you wish so. And then I have the accordion content, which is going to be showing a box with the textual response from the API. So I can save that. And lastly, we are exporting the single query. Then this single query is going to be used in a query list, which we are going to be taking a look at right now. So for the query list, we are simply going to be showing a box, which is going to have some title, and then we are going to be mapping through all the queries. And for every query, we are showing a box with the accordion, which we have just implemented. That is it for the query list. Then we want to have a module. When we ask the questions, it's going to basically open a module. So let's take a look at it right now. Firstly, we are going to have a content, which is basically going to be the query value for the query input. Then we are going to implement a handle submit method. We are going to prevent the default behavior and stop propagation of the event. And then we are going to be asking the responder, which is basically the method from the API list which we have implemented. And finally, we are going to hide the module when the response or the query is triggered. For the front end, we are going to be showing a module, which is also a component from the Strapi design system. Inside the module, we are going to have a header with a typography, which is going to say ask responder. Then there is a body with a text input with some placeholders and so on. On change, we are setting the content, which, as I said, is the query. And finally, we are going to have a footer, which has start actions and end actions, which is going to cancel the query or submit the query, actually. So that's it for the module. And finally, we are going to be taking a look at the home page, which is basically the main page currently for the plugin. So firstly, I'm going to be using a React query, as I said. So we have to create a query client, which is going to be wrapping all the subcomponents from the page. Then we are going to have a state, which is going to be deciding if we should open the module or not. We are going to be using the useQuery hook. And finally, we are going to be fetching the data using the useQuery, which is calling the request list.getAllResponses method. Then we are going to be having a mutation, which is going to handle submitting the query to the backend. Then we are going to implement an askResponder method, which is going to be passed as a prop to the responder module, which we have implemented earlier. Then we are going to open the module with a button, so we create a little handler for that. And then we are going to decide if there is some query which is currently loading. So for the JSX, we are going to be returning a query client provider, which, as I said, is wrapping all the subcomponents so that they can use the useQuery client hook. Then we are creating a layout which is not going to have any side navigation. We are going to give it a header and an action, which is basically a button, which is going to open the responder module. Then we have the content layout, which is going to show a loader if any of the queries or mutations are in progress. And if they are not, we are going to basically render an empty state if there is no data or if the queries are empty, meaning that the user has not created any query. For that, we can use the Strapi design system empty state layout. And if we have some queries, we are going to be rendering a query list. Finally, we are going to be rendering the module if it's opened. So we are basically done with the implementation. Let's just jump into a terminal, run the yarn develop command, and after a couple of seconds the app should be built, it should be up and running, and then we can take a look at the browser. Yeah, we can see that it's running on localhost 1437, so let's open it. We have the content manager, we can see the responses that are currently none, and we can open the responder plugin. So we have currently no queries. Let's ask some. This is the model, so we can ask anything. I can ask it, what's the weather today in Brno, and submit it. This is going to trigger a response to the backend, and as we can see, we have already gotten the response. And ChatGPT says, I'm sorry, I cannot provide real-time information as an AI language model. Alright, maybe we can ask it if we want a joke. Sure, here's one for you. Why don't scientists trust atoms? Because they make everything up. So, this is probably a good place to end this talk. Thank you for listening. If you have any questions, feel free to write comments, or maybe you can contact me on LinkedIn and get in touch. Thanks and have a nice day.